Hundreds of years ago, the only way to get power to a place like this would be through wood, and firewood specifically. There's a lot of kinds of wood you can find, little twigs, green wood, which is wood that's just been recently cut. But to really get wood that would burn well, the wood had to kind of sit around for a while, kind of like you can see behind me. When you burn wood, you're basically doing a chemical reaction, and you're using energy from heat, which you can create through sparks, through flint, through lightning if it's by accident, and using that energy to catalyze that reaction. Catalyzing a reaction basically means you're putting a little energy in so you can get some energy out. And this reaction takes carbon that is in every living thing and also in plants where the wood comes from, and then uses oxygen to light it on fire. And when you combine that oxygen, there's a chemical reaction that releases some energy, and you get some heat out of that. Now, there's other things that come out of it. Carbon and oxygen together make carbon dioxide, and all the other materials in the wood are burning too, and they make other kinds of smoke and pollutants and things. Burn too much wood and you breathe it in and you can get really sick. But the other thing is that wood only has some carbon in it. It has a bunch of other trash and it doesn't burn that well. It also runs out really quickly. It burns pretty fast. So although wood smoke is warm and it can feel really good, it's not really useful as a source of energy for a long time. More than that, you can see I'm standing on a lawn. Most of the land eventually runs out of trees. Trees take a long time to grow. And if you run out of wood and you run out of trees, you run out of fuel. So although you can grow more trees, it would take too long to grow the amount of trees that everyone in this place needed. They needed another source of energy, something that would last longer and wouldn't run out as fast. Over long periods of time, forests eventually will fall down and die, and the trees will fall down. And some forests last a long time, but some forests live in areas that are kind of bog-like, swamp-like, and eventually those trees, the wood, will settle at the bottom of those bogs. Certain kinds of trees can then turn over long periods of time into coal. In order to turn trees into coal, you need a lot of heat, a lot of time, and a lot of pressure. And so those layers of trees, as they die and settle in the bottom of these bogs, they'll have more and more soil settling on top of it. And the pressure of those new layers of soil will press all of the carbon into these nice little, neat kind of coal particles. Carbon is just an element, but carbon can take different forms depending on how it's pressed. Coal is pure carbon, but so is a diamond. And depending on how much pressure you have and where you find it, you would either get coal or a diamond, or even the graphite that's in your pencil, which is also pure carbon. One of the properties of coal is that it burns for a long period of time. And similar to wood, you can set it on fire easily, but unlike wood, it doesn't run out as fast. It still does generate a lot of pollution, though. But back in the day when houses like this were built, this little brick hatch you can see, it looks like new brick, would have been a door. And you would actually put coal into the house that you could then use to heat the home and power different, stoves and things like that. This little hatch here, you'll see on some historic homes actually having a metal door on it. You would actually have to get the coal from some place nearby and then go over to this hatch and lift open the door and then pour the coal in and close the door and then go inside your house and use the coal and dump it into stoves and furnaces and things. Now, the good thing about coal, unlike wood, is that it lasts longer. Where the bad thing is, just like wood, it does generate a lot of smoke, soot, ash, pollution, and one of the main things that all of the burning does is generate carbon dioxide. No matter what you burn, if it's carbon, you add oxygen to it, carbon and oxygen makes carbon dioxide, which is just a combination of those two elements and molecules. And so that does get into the air. While it doesn't hurt us to breathe in carbon dioxide, in fact, we breathe it out just by making energy ourselves, it does have other impacts on the environment that we'll be learning about. Now, coal started to fall out of favor for a lot of in-home usage for a long time. It obviously can generate heat, but it gets used up pretty quickly. And in order to actually use it in your home, you have to keep picking it up and getting it and bringing it into your home. And one of the things we were able to develop is the technology to use other fuels, specifically natural gas. You'll see these pipelines outside of a lot of homes. And these pipelines carry gas in them. And by gas, I mean specifically a type of air type thing, but it's methane. Methane can be mined for and drilled for, but can't be captured the same way that coal can, because coal is a solid. So you can just pick it up, put it in a bucket, put it on a train, put it on a boat. But this has to get captured in a way that can contain it. Since there's a gas, it could just float away. So we needed the technology to do that, and one of the most common ones now is hydraulic fracturing. You use pressure from water to basically break layers of rock, release the gases, and capture them. But most of the gas that was mined for before, drilled for before, was in the ocean or in areas that were like like old oceans. And we used other forms of technology to get that. Usually it was a byproduct of drilling for oil at the time, or petroleum. Now this gas can be burned and used for heat. It also can be used for electricity in some cases, although when it's coming into the home, it's not used for that because you don't have a way of generating any electricity from that. Just like coal, it has a lot of carbon in it, and when that carbon is burned, it does generate carbon dioxide. But unlike coal, it doesn't generate a lot of the other pollutants like sulfur dioxide. But still, the carbon dioxide does have a role on the climate, even if it doesn't have a role for our lungs. One of the other things you can get when you're burning carbon dioxide is carbon monoxide, which is not a fully formed carbon dioxide, but it still has oxygen in it. Carbon monoxide is a little worse for us, though, because it binds to our blood cells and can take the place of oxygen, causing us to suffocate over time. When this home was built, it was built with a fireplace, which used to run on coal. Now, obviously, to shovel a bunch of coal in here and then burn it in your home, it would make you sick. It's a lot of hassle. Now, this fireplace is actually running on gas. Now, gas is made of methane, which is CH4 as its formula. C is carbon, H is hydrogen, and so this is 1 carbon atom and 4 hydrogen atoms. Coal is just C, just plain carbon, pure all the way through. But both of them, when you burn them, have carbon in it. And when you burn it, you basically break apart those molecules, releasing a lot of energy. That energy comes off as heat. Now, you add oxygen in order to burn something, which is why if you want to put out something, you can drown it with water or suffocate it with a blanket, which cuts off the oxygen and cuts off the fire. Both of those things that would remove oxygen from us also remove oxygen from a fire. But just like when we make energy, we have to produce carbon dioxide. Same thing happens when you're burning carbon. So here, this gas fireplace will also release hydrogen. That hydrogen, when it bonds with oxygen, makes H2O, or water. In this form, it'll be really hot water, so it makes water vapor or steam. So those are the 2 things that come off of this fireplace. But there's a third thing that can happen. If the carbon dioxide doesn't form completely, it'll make carbon monoxide. And you always get a little bit of it if you're not burning it cleanly or filtering it or venting it right. Which is why up there you see a carbon monoxide detector. Because when carbon monoxide gets into our bloodstream, it can bind to the places where oxygen is supposed to bind. And it can prevent us from being able to breathe in oxygen. Well, then we suffocate. This is why when you're burning fuel in a car in an enclosed space like a garage, you can suffocate. And when you're burning coal or some sort of fire in an exposed enclosed space, you can suffocate as well. You always want to have venting, which is why in this chimney, it goes all the way up and it vents. Now, in order to turn on a fireplace like this, you first have to turn on the gas. The gas line is right here, and gas, like I said, can heat anything, but it has to be ignited. And when you turn it on, you have to add some sort of an ignition or catalyst to it. In this case, I'm going to use a lighter as my catalyst. The catalyst is something that starts a chemical reaction, and burning is just a type of chemical reaction. You'll then get energy coming off of it, and that is a kind of a waste product of that reaction, but we use that energy to heat ourselves. And when we are making electricity, we use that energy to convert into electricity that we can use to power other things. I can't do that in my home without a generator. I needed somebody at a power plant to do that for me. Nonetheless, let's take a look at this catalyst reaction, starting with methane, CH4, then adding a little bit of oxygen to it, and there's my fireplace. Now, this type of reaction that takes place still generates carbon dioxide, and like I said, it's not toxic for us to breathe it in, but all of that carbon dioxide going out of the chimney into the air and then getting produced by everyone who's burning natural gas everywhere in the world, everyone who's burning gasoline everywhere in the world, and more people having access to that fuel and using that fuel everywhere. Well, you end up with a lot of carbon dioxide in the air, and it doesn't just go away. It stays there, and we'll learn a little bit more about what that carbon dioxide does over time.